Hey there, chemistry students. So we are still working on describing the organization of the modern periodic table. And to that end, today I have a lab for us called Periodic Trends and the Properties of Elements. So let's take a look at what we're going to be doing in this lab here today. Okay, so for this lab, I have here my lab handout, which you probably have as a digital copy. And I also have a bunch of other stuff around me here. I have 3 metals in front of me. Okay, this here is calcium. This here, there's a little, you can see the ring, a little metal in there. This here metal is magnesium. And then I have some good old best budget aluminum foil. Okay, so I have calcium, magnesium, and aluminum. And these 3 metals are the subject of our lab today, right? If you go to the periodic table and you take a look at these, what you're going to find is that calcium and magnesium are both in the same column together on the periodic table. They're in the same family. Now, if you don't recall, that family is called the alkaline earth metals. You're also going to find that magnesium, which is atomic number 12, and aluminum, which is atomic number 13, are in the same row together on the periodic table. Now, if you recall in the last lesson, we talked about elements in the same column have similar properties. And that's kind of the point of the lab here today, is to look and see, do elements in the same row have the same properties, or do elements in the same column have the same properties? We already know the answer. But let's, do the lab, and we'll investigate that for ourselves here. So hopefully we see the ones in the same column have the same properties. So what we're going to do is I have a little spot plate here, and I'm going to try to film this in a good way that everybody can see it really good. We're going to put some water in some of these spots, and then we're going to put some calcium in the water, put some magnesium in the water, put some aluminum in the water, and see what happens. And then for the second part, we're going to put some acid in 3 of the spots. And then we'll put some calcium in the acid, we'll put some magnesium in the acid, and we'll put some aluminum in the acid, and we'll see what happens. Okay? So let's get to that and see if I can film this in a really good way where you can see it nice. Okay, after trying a few things, I have come to the conclusion that probably the easiest way to film this so that you can see it the best is to simply pull the camera down. Okay, so now I'm going to put a little white sheet of paper under this, just to kind of make it maybe a little bit easier to see. And I have here some water. And, if you consult the directions, it says to put, exactly so many drops of water in here. The amount of water really doesn't matter. So all I'm going to do is I'm going to take some water up in my pipette, and I'm going to fill 3 spots here about halfway with water. You get a little bit more for that one. Okay, so there's 3 spots with water in it there. And what I'm going to do first is I am going to get a thermometer, and I'm going to measure the temperature of the 3 spots of water. Now, what's the point of measuring the temperature of the 3 spots of water is I just want to see if it changes after I add the metals to it. So this one, they should all be the same temperature. This one is about 21 degrees Celsius. It's also 21 degrees Celsius. And this one is also 21 degrees Celsius. And then, we'll go ahead and we'll see what happens after we add our metals to them. And let me see, my first one here I have is calcium. And I am going to use some forceps to take out a little piece of calcium. Can't see all the action here, but here's a little piece of calcium. There you go, a little piece of calcium, and I'm going to drop it in here and get ready. Wait for it. Now maybe you can see on the video, my piece of calcium is starting to bubble. There's some bubbling going on. There's a whole lot of bubbling. I can hear it fizzing. It's fizzing and bubbling. I hope you can see that pretty good on the camera. It is, ooh, there it goes. And there's some steam coming up. That is definitely a vigorous reaction going on there. So here's calcium and water. We'll give that a minute to do what it's doing. And I'm going to put my thermometer in there. And oh boy, is it going up. So yeah, it's hot in there. I'm not going to measure the exact temperature, but I know it got hot in there. My temperature went up there. So that's what happened there. I am also going to take a little piece of what's called litmus paper. And litmus paper, or red litmus paper, will turn blue in something that is alkaline. Something alkaline is like it's a base, right? Remember, two of these metals were called alkaline earth metals. So let's see what happens here, right? Is this alkaline? Did it turn blue? You bet it did. So what I put in here, what I got here after I added calcium to water is definitely alkaline. It's still doing a little bit of steaming there, so that's pretty neat. Right, the one in the middle here, I am going to add a piece of magnesium. So let me cut a little piece of magnesium off of this ribbon. I know you can't really see everything that I'm doing. Here's my piece of magnesium, and I'm going to drop that in the middle well here. And I know it's super exciting watching this. Okay, now I paused the recording for a few minutes there, and you might be able to see, I don't know if you can notice, there are some small bubbles around the magnesium. So, we saw a huge reaction out of that calcium. Out of the magnesium, are we seeing a reaction? Yeah. Is it as vigorous as with the calcium? Not at all, right? But, it's still having a little bit sort of a reaction. I'm going to put my thermometer in here and see if the temperature has increased at all. It may have increased a little bit, maybe, and I might just not notice. Might not be enough for me to really notice. Yeah, and I don't really notice much change. And then I'm going to put in my litmus paper and see if it is at all alkaline. And, you can see there's maybe a slight tinge of blue on there. I mean, not very much at all. But, there might be a little bit of change on there. So, magnesium acts kind of like calcium, but way less in your face. We're going to call calcium in your face. And magnesium, not so in your face. Okay. And then our third metal we have here is aluminum. I'm going to take a little piece of aluminum foil, I'm going to crumple it up, and I'm going to drop it in here in this third one, and we'll see what happens. I'm going to pause the video, let a little bit of time go by, and then, we'll see what it looks like there. Okay, a little bit of time has gone by there, and with the aluminum, I've noticed absolutely nothing happens. It's just like floating there in the water. You do notice, though, as time goes by, that the litmus paper in the magnesium well is getting bluer and bluer, and I've seen a few more bubbles come off of it. So, we can see that magnesium is kind of reacting there with the water. But let's go ahead and let's take a look and see if the temperature has increased at all with this aluminum. And I'm not going to try forever because I know the temperature is not really increased at all. And then let's put a little piece of litmus paper in there and see if we get any change out of it. Here is a piece of litmus paper going in with the aluminum. And what do I see happening there? I see absolutely nothing happening there. So we can see that calcium and magnesium sort of behave the same way, and aluminum does not. So that's kind of the point there. Okay, for the second part of this, I have cleaned up the spot plate, and This time we're gonna do pretty much exactly the same. I'm gonna do it a lot faster though. But instead of using water, we're gonna put in some hydrochloric acid. Okay, and your lab handout says to use 0.5 molar hydrochloric acid. 0.5 molar. That's the concentration of the acid. I'm actually gonna use 3 molar hydrochloric acid, so it'll be 6 times as concentrated. And maybe it'll be more interesting than using half molar. We'll see. I don't know. Maybe I'll blow things up. Who knows? It's chemistry. Anything could happen. All right. So here, take a look at my spot plate, and I am going to add my hydrochloric acid into 3 of the wells. So I'm gonna get my pipette. I'm gonna draw some acid in there. I'm gonna fill them about halfway. Maybe a little bit more in some of these. Okay, there's my hydrochloric acid. And now I'm going to take, just to kind of take a little shortcut, I'm going to take some litmus paper. And I'm going to have the litmus paper just kind of already sitting in there. And you'll see at first it does not change blue because the acid is not alkaline. The acid is actually the opposite of what alkaline is. Kind of dropping paper everywhere. Oh well. Alright, and now let's kind of go in the reverse order. We'll do the aluminum first. Put the magnesium in the middle. Get there in 1 second. And then we'll put the calcium on these. Okay, that aluminum's been in there for a minute. You see anything happening just yet? I don't see anything going on there. If we leave it for a few minutes, we might get some bubbling. We'll come back to it. Take another look at it in a few minutes. Let's put the magnesium in and see what happens. Oh, you see, that's a little bit more vigorous than what happened in water, isn't it? See the magnesium reacting with the acid? It's got some bubbling, it's got some steam coming off. I'm sure the temperature in there is going up. Yeah, our piece of magnesium is broken apart, and looks like the magnesium is almost gone. Yeah, there it's gone. And our acid hasn't turned alkaline yet. The litmus paper has not changed color. I bet you if I put in some more magnesium and some more, or if I had used a lower concentration of hydrochloric acid like the instructions told me to, then it probably would have turned blue. It probably would have turned alkaline. Now, well, let's take back on our aluminum. We see anything with the aluminum yet? I see a tiny bubble in there. Just one. Alright, now let's do our calcium. Everybody stand back. We'll see what happens here. There it goes. And once again, I don't see the litmus paper changing, but I bet you if I had used a lower concentration, like the instructions told me to, then it would probably be turning blue at this point. In fact, you know what? Let's just try that real quick. Alright, well, I was getting the lower concentration acid here. The litmus paper turned blue with the calcium. But here I have, this is the right concentration that the instructions told me to use. I'm going to put in these wells. And then we'll put in another calcium and magnesium. I'm pretty confident that aluminum's not going to do very much at all. But, you know, just to take a look at the calcium and magnesium, according to what the directions actually told me to do, and not what Mr. McQuinn wanted to do. Okay, here's the magnesium. You see that's much less vigorous than it was before. And let me get calcium in there. Here, we'll put the litmus for that. This one I'd expect to still be pretty vigorous. I don't know if you noticed while you're watching this, but at this point the aluminum is starting to have a few bubbles coming out of it there. It's starting to react just a little bit. It took quite a long time. And I can see the litmus paper in the calcium right here is turned blue. And the magnesium here is there's a tiny little tinge of blue there. So that magnesium is not being as vigorous as the one in the more concentrated acid was. Took a long time for that aluminum to do very much. Alright, there was some fun stuff there. Okay, with all that complete, now we'll go ahead and we'll kind of answer the questions that are on your lab handout, or your digital copy to the lab handout. On the back, it gives me a little data table to fill in to record what I observed happening while the experiment is taking place. My data table should be appearing right there. So there's my data table. You can fill it out and whatever you observed happening. And then the questions below. Question number 1 says, rank the 3 metals in part A from most active to least active. And I think we'd all agree that the most active metal, most reactive metal, was the calcium, followed by the magnesium, and trailed by a long shot by the aluminum. So the most reactive is calcium, the least reactive, aluminum. Number 2, it says, write a sentence that describes the periodic trend in metal reactivity down a vertical column of the periodic table. So the 2 metals that we looked at that were in the same group were magnesium and calcium. And magnesium is higher in that group than calcium is. So as you go down the group, what happened to the reactivity? Did it get more reactive or did it get less reactive? Since we were going down and the calcium was more reactive, it gets more reactive as you go down the group. So number 2, I would say it gets more reactive as you go down the group. Number 3, it says write a sentence that describes the periodic trend in metal activity within a period, within a horizontal row on the periodic table. So the 2 we looked at that were in the same row were the aluminum and the magnesium was more reactive. Magnesium is further to the left, so I would say as you go from left to right, they become less reactive. Number 4, it says locate the following metals on the periodic table: magnesium, potassium, and sodium. Based on your answers to 2 and 3, rank these metals in order of their expected activity from most active to least active. So there was magnesium, potassium, and sodium. So potassium and sodium are in the same column together, but potassium is lower, so I'd say that one's more reactive, followed by sodium, which is in the same column, and then the other one there, magnesium, would be the least reactive of those 3. All right, finally, 5th question, number 5. It says litmus paper changes color in acidic and basic solutions. The word alkaline is a synonym for basic. Why do you think the 2 words alkaline and earth are used to name the group 2 metals? Well, alkaline, because you saw with the litmus paper, the water became alkaline, right? And then the word earth used to be used for compounds of oxygen. So, these are metals that react with oxygen in a 1-to-1 ratio, which you didn't see from the experiment. I just happen to know that. So they form alkaline solutions, and they form compounds in a 1-to-1 ratio with oxygen. So alkaline, earth. So there's those questions. Okay, just for fun, I thought we would try this with the most concentrated hydrochloric acid that I have. This is 12 molar hydrochloric acid. Remember the ones we used before, I started with 3 molar, so this is 4 times as concentrated as that one. And then the one that the directions had actually told me to use was 0.5 molar, so 24 times as concentrated as that. So let's see what happens. You'll notice I put on gloves to handle this because it gets a little burny. So let's put some of this into our wells. And I am going to stand back for this one because I don't know what's going to happen. And I'm going to keep them a little bit further apart than I did before. I'm going to put this one way over here. And I'm going to put this one way back here. Alright, so observe. We'll do the aluminum first. Put the aluminum over here. Put the magnesium over here. And the calcium. Alright, fun stuff there. You can see the aluminum is completely gone. Or I'm sorry, that was the magnesium, which is completely gone. The aluminum is also completely gone. And it's left me with a soup of gray. And then the calcium also completely gone. It's still kind of fizzing in there. So there you go, with some of the most concentrated hydrochloric acid that I have here. Great fun. Alright, there you go. So hopefully that lab helps us get a little bit closer to being able to describe the organization of the modern periodic table. We saw in our lab today that as you go down a column on the periodic table, the elements get more reactive. As you go across the period, they get less reactive. And then the ones in the same column together tend to behave in similar ways. So hopefully it helps us describe the organization of the modern periodic table.